Boys and girls, this is Mr. Manise, and in this video I'm going to walk you through the notes for the lesson on circles on the coordinate grid. So this is our first lesson in a series of lessons in this unit where everything we're going to be doing involves the coordinate grid at some point. So this is a little bit of a tricky lesson, guys, so really needs you guys to buckle down and pay attention so you can get some of this stuff. And on the surface it'll look complicated, but after you do several of these, it actually won't be that bad. Alright, so the first thing that I want to talk about is what is the relationship between Pythagorean theorem and the distance formula. If you guys go back in your time machine all the way back to coordinate algebra, if you will remember that the distance formula is over here on the left. We got Pythagorean theorem. Over here we got the distance formula, and the distance formula is defined as the square root of x2 minus x1 squared is the difference of the x's squared plus the differences of the y squared, y2 minus y1 squared. Okay, so just keep that in mind. Over here we're going to use the Pythagorean theorem to find the distance between these 2 points. So I'm going to plot 2 comma 7, right 2 up 7, and then I'm going to plot -1 -4. So left 1 down 4. Okay, I want the distance between those 2 points. So if I want to connect those, I want this, I want that distance. Okay, if I'm using Pythagorean theorem, let me zoom in here just a little bit. If I'm using Pythagorean theorem, then I need to draw myself a right triangle. So the distance that I just drew ends up being the hypotenuse, and then I have this leg down here, and then I have this vertical leg up here. Okay, that's obviously going to form a 90-degree right angle. Okay, so now to use Pythagorean theorem, that's going to be a squared plus b squared equals c squared. Okay, well, let's let this short piece be my a. Well, what is the length of a? Well, I just count the blocks. 1, 2, 3. So that leg is 3, and then for the b, I'll count vertically. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So that distance is 11. That vertical distance is 11. Okay, alright, so now to find the hypotenuse, we'll let this be my x or my c, it doesn't matter. I'm just going to do a squared, so 3 squared plus b squared, 11 squared equals c squared, or in this case x squared. And then I'm going to plug that into my calculator. 3 squared plus 11 squared, that gives me 130, equals x squared. And then I take the square root of both sides, and I get x is equal to the square root of 130 is about 11.4. Okay, alright, so we get this distance, the distance between these 2 points is 11.4, which is basically the hypotenuse of a right triangle. Over here, let's do the exact same thing with the distance formula. And it doesn't matter, guys, which ones you let be the x1s or the x2s, it doesn't matter. I'll let these be the 1s. So the 2 will be my x1, the 7 will be my y1, and these will be my 2s, x2 and y2. And now I'm simply going to plug these numbers into the distance formula. So distance is going to be the square root of x2, which is this guy, -1. And then it's minus x1, so minus 2. We're going to square that, okay, and then that's going to be plus, and then we've got our y2, which is -4, minus y1, which is 7, and then we're going to square that. So distance is equal to -1 minus 2 is -3, so we're going to square -3. -4 minus 11 is -11, so we're going to square that. Okay, -3 squared is just 9. Anytime I square a negative, I get a positive. 11 squared is 121. And when I add those together, I get, oh look, the square root of 130. And I still get the exact same thing. Whoa. Pretty cool, huh? So the point of me doing this is to show you guys that the distance formula is nothing more than the Pythagorean theorem on the coordinate grid. Okay, so the Pythagorean theorem is a squared plus b squared equals c squared. Well, this x2 minus x1, this whole guy, I'll do this in green. This whole guy, that's like my a. Okay, so I'm basically doing a squared. The y2 minus y1, that's like my b. Okay, because x2 minus x1, all we're doing, guys, is we're finding the horizontal distance between the two x values. That's the green piece. And then for the differences of my y's, that's just going to be the vertical distances between my two y coordinates. Okay, so this green piece is like the x2 minus the x1. What's the horizontal difference? And then y2 minus y1. So this 3, that's like my A, and the 11 is like my B. Okay, and so that's where this is basically, but instead of a D for Pythagorean theorem, this is like my C. Okay, so if I change this to a C, there we go. And then C is going to be equal to the square root of A squared plus B squared. This is just another way of doing Pythagorean theorem. Okay, so I want you guys just to keep that in mind as we go through this lesson here. Distance formula is just Pythagorean theorem. Okay, so let's start with our notes here. We're going to start with a nice little warm-up, and it says find the distance between each pair of points and the midpoint of the segment with the given endpoints. So let's write our distance formula up here again. That's going to be the square root of the differences of the x's, x2 minus x1, that's like my a squared, and then plus y2 minus y1 squared. So here that's like my a squared plus b squared. Okay, and then the midpoint formula, you guys may not remember that one. For the midpoint, the way I think about midpoint, middle, median, average, right in the middle, it's basically just the average of your x's and the average of your y's. If I want to find the middle of a line segment right there smack dab in the middle, then I'm going to find the averages of my x values, and I'm going to find the average of my y values. Okay, so this is just going to be x1 plus x2 divided by 2, comma, y1 plus y2 divided by 2. The average of the x's, the average of the y's. Okay, so for this first one, I will let these be my 1s. Typically, I just let whatever coordinate point comes first, I let those be the 1s, and then the other one be my 2s, but it doesn't matter. Alright, and so we plug this into our equation, so we have distance is equal to x2, which is 4, minus the x1, which is 1, we're going to square that, plus y2, which is 1, minus y1, which is 5, we're going to square that. That comes out to be, you plug all this in, I'm going to skip this just for the sake of the lesson, guys, I want to go kind of quick. Plug all that into your calculator, that comes out to be the square root of 25, which actually comes out to be 5, so the distance is 5. Midpoint is going to be the average of the x's. So what's the average of 4 and 1? Well, you add them together and divide by 2. The y-coordinate is going to be the average of the y's. What's the average of 5 and 1? So we're going to add the 5 plus 1, and we're going to divide by 2. So for my x-coordinate, 4 plus 1 is 5 divided by 2, so that's going to be 5 halves, or 2.5. 5 plus 1 is 6 divided by 2, and that's going to be 3. Okay, so for the next one here, we're going to do the same thing. Distance is equal to the square root of, I'll let these be the 1s, I'll let these be the 2s. Actually, for sake of time, guys, you know what? I'm going to let you guys pause the video. So I'm going to let you guys do this on your own. I want you guys to find the distance and the midpoint on your own. So go ahead and pause the video and work those out. Okay, so if you come back, again, for sake of time on this video, I'm not going to go through all of this. You should have gotten for the distance, you should have gotten the square root of 50. Square root of 50 is approximately 7.1, and for the midpoint, you should have gotten 3, 2, negative 1 half. 3 halves and negative 1 half. Okay, so that's just a little warm-up from last year in algebra, coordinate algebra. Okay, so the point of today's lesson, just when you thought we were done with circles, we're not quite done with circles yet. Okay, so what we're going to be doing in this video is writing the equation of a circle, graphing a circle, and then using the equation of a circle and the graph to solve problems. So at the end of the lesson, this is what you're going to be able to do. Write the equation of a circle, graph it, and apply it. Okay, so let's look at this very, very important slide here in your notes. All right, so it says, we use the distance formula to find the equation of any circle with radius r and center hk. Okay, so here is a circle on the coordinate grid, and this point, guys, it looks like the origin, but it's not necessarily the origin. Okay, this could be any point. This could be sitting in the first quadrant at 4, 8, or this could be sitting in the third quadrant at -12, -27. Okay, it's just the center point of my circle. All right, so it says we're going to use the distance formula from a point on the circle in the center of the circle to find this radius. Okay, and so there are two things, guys, that you need for all of these problems with the circle. You need the center, you need the radius. You need the center, you need the radius. I need those two things. Okay, so basically what we're trying to find here, if I want the distance of the radius here, then I'm just going to use the distance formula. Okay, so once again, I'm going to write it again. Square root of x2 minus x1 squared plus y2 minus y1 squared, distance formula. Okay, but now we're not talking about distance, we're talking about the actual radius. Okay, so this point on the circle is going to be some point, x comma y, 4 comma 2, 6 comma 8, whatever. The center of the circle, we're going to call this h comma k. Okay, h comma k. It's kind of like the vertex form when we were dealing with quadratics, using an h and a k. It's just another coordinate point, 1 comma -2, or whatever. All right, so instead of distance, I'm going to write the radius. Okay, so now instead of x2 minus x1, I'll let these be my 2's. This will be like my x2 and my y2. I'll let the h and the k be like my x1 and my y1. Okay, so I'm just going to stick these into the equation. My x2 is that guy, which is still just x, minus x1, which we're saying up here, we're going to call that h. It's just the x-coordinate of the center of the circle. That's all that is. Okay, plus y2, which is just the y, minus y1, which is the k. And then I'm going to square that. Okay, and now I want to get rid of this square root. So I'm actually going to square both sides of the equation. So if I square both sides of the equation, then I'm going to have r squared. And when I square the square root of something, these guys just cancel. So the square root and the square just cancels. And I'm left with x minus h squared plus y minus k squared. And that, boys and girls, is the equation of your circle. Standard equation of a circle with a radius r and a center hk is x minus h squared plus y minus k squared equals radius squared. This is a fancy way of just doing the distance formula. Instead of the hypotenuse, instead of a distance, we're talking about the radius of a circle. We're still doing the differences of my x squared, that's like my a squared, plus the differences of my y squares, that's like my b squared, equals c squared. This is still just Pythagorean Theorem, that's all it is. All right, so here's how this works. Given the center and the radius of the circle, I'm going to find, given the equation, I want to give the center and the radius. Okay, one thing you guys are going to have to understand, I want you to write this in your notes. These two guys, every time we've had a binomial with a parentheses, what have we done with the signs almost every time? We flip them. So I want you to write in your notes, flip the signs. Every time we've solved a quadratic, every time we've done something like that, we flip the signs. You may say, why do we flip the signs? And the answer is because we're subtracting h. If it were x plus h squared, then I wouldn't need to flip the signs. H is, if it's x plus 3, then h is 3. So their equation is a minus sign. So that's why we have to flip it, because we're subtracting that value. You may say, well, that's kind of weird. Why is the equation minus then? Why can't we just put a plus in here? Why isn't the equation x plus? Well, that's because of the distance formula. We are subtracting values here. We're finding the differences of the x's and squaring it, the differences of the y's and squaring it. So we got subtraction here. That's why we have to flip the signs. Okay, here we go. X minus 2 squared, this is going to be my h, and the 3 is going to be my k. But we have to flip the sign. That's a -2, so I'm going to flip it. So my center is 2 comma flip. My center is 2 comma 3. Simple as that. I want the radius. Well, this is r squared. This 49 represents r squared. I don't want r squared. I want the radius. So I'm going to have to take the square root of 49, which is 7. Okay, this one here, that looks kind of weird. I don't see any parentheses. I don't see any minus. I don't see anything. Well, x squared, isn't that the same thing as basically x minus 0 squared? Yes, it is. So anytime you don't see a parentheses, guys, the coordinate point is just a 0. So I have an x squared and a y squared. So my center is just 0, 0. We're literally sitting at the origin. If 12 is the r squared, I'm going to have to take the square root of that. So my radius is the square root of 12. Or, I don't like to leave things as radicals. Square root of 12 doesn't have any meaning to me. I'll say or 3.5. Okay, so my radius is about 3.5 on the coordinate grid. Okay, now over here I do have a set of parentheses, so I do need to flip that sign. So for my h, I flip this sign, that's going to be -4. And then I don't have a parentheses for the y, so that's just going to be a 0. Alright, for the radius, I'm going to take the square root of 4/9. That's the same thing as the square root of 4 over the square root of 9. So the radius is just 2 over 3. Square root of 4 is 2. Square root of 9 is 3. Okay, so you might want to pause the video for a second, just let that sink in. Okay, let's move on. Alright, on the next sheet, now we're going to go backwards. Backwards, is that a word? Backwards? Alright, so now they are going to give us the center and the radius, and we have to come up with the equation. Okay, so if my center is 0, 0, there's a 0 there and a 0 there. Okay, so this is basically like x minus 0 squared plus y minus 0 squared. Okay, and that's going to be equal to, now my equation, I do need an r squared. So if they give me the radius, I need to square that. Square the 3. The zeros just go away, so my final equation is just x squared plus y squared equals 3 squared, which is 9. Okay, flip those signs. Now, when this is negative, guys, okay, it's going to be x minus a -5. There's that lovely double negative, okay, plus y minus another double negative squared equals 1/5, and then we got to square that. Because remember, it's r squared. They give me the radius, I got to square it to put it in the standard form of the circle. Alright, so that is going to give us the equation x minus a -5. That's going to give me x plus 5 squared. Double negative, that's going to be plus y plus 6 squared. And when I square 1/5, square the 1 on the top, that's just a 1. Square the 5 on the bottom, and that's just a 25. So x plus 5 squared plus y plus 6 squared equals 1 over 25. Alright, last one here. They give me a center of 0. So that's like x minus 0 squared plus y, flip the sign, y minus 7 squared equals 3 root 5, and then we're going to square that. X minus 0 squared is just x squared plus, keep this the same, y minus 7 squared. How in the world, Mr. Manice, do I square 3 root 5? Calculator. 3 square root of 5. Get a number. Square it. 45. Boom. You're done. That's all you got to do. Use the calculator. Calculator's your friend. Alright, so now we are going to work on graphing a circle. Graph in the circle. Alright, so now they're going to give us the equation and we got to graph it. Here are the steps up here at the top. Step 1 says plot the center. I need the center, and I need the radius. I need those two things. Plot the center, use the radius to plot 4 more points, and then sketch the circle. Okay, so for my center, what do? I flip the signs. That's my H, that's my K. Flippy flip. 3, flip that sign, -1. That's my center. Let's go ahead and plot that. 1, 2, 3, down 1. And then my radius, if this is r squared, then my radius is the square root of that, so my radius is 6. Okay, so now it says use the radius to plot 4 more points. Okay, I'm going to use this radius of 6. So how do I plot a circle? Let's go north, south, east, and west. Okay, so I'm just going to count. 6. 1, 2, 3, 4. What comes after 4? Oh yeah, 5, 6. Okay, and then let's plot a point. Go left. 1, 2, 3, 4, 5, 6. Plot a point. Go down. 1, 2, 3, 4, 5, 6. Plot a point. Let's go east. 1, 2, 3, 4, 5, 6. That's the best I got for you. It's been a long time since I've taken a foreign language. Okay. All right. So now we want to plot a circle. Okay, so guys, you can do this a couple of different ways. I'm going to get out, you don't have to do this. I'm going to get out a compass and do it. You don't have to do this, but I'm going to do it anyway. So I'll put my needle right here, and I'm going to draw, wow, that did not work out. Y'all like that circle? That was pretty good, wasn't it? You guys are probably rolling the floor right now laughing. That's okay. That's why I don't like these old cheap compasses. Alright, so let's do it the hard way. So I'm just going to kind of do it like one quadrant at a time. Just sketch it in. Doesn't have to be perfect, guys. If it's not perfect, I'm going to take off 100,000 million points. Just kidding. Let's plot our circle. Y'all are probably still laughing at my compass, aren't you? It's okay. You can laugh. Okay, so there is my circle. Alright, let's go on to the next one. Let's do it again. Alright, I need the center, I need the radius. Okay, there's nothing, no parentheses here, so that coordinate's just going to be 0. So for my center, that's going to be 0, comma, and then what do I do with this sign? Flippy flip, 0, comma, 5. Okay, I need the radius. This is r squared, so my radius is actually going to be the square root of 18, which is approximately 4.2. Okay. Alright, so let's plot our center. 0, go up 5, 1, 2, 3, 4, 5. And then how in the world do I plot 4.2? Well, let's go 1, 2, 3, 4, little mo. Y'all remember that nursery rhyme? 1, 2, 3, 4, little mo? That's because it doesn't exist. I just made it up. Alright, so let's count. 1, 2, 3, 4, little mo. 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 And let's go ahead and draw our circle. Just sketch it, doesn't have to be perfect. I kind of like to do it a quarter at a time. Okay, alright, so there's our circle. Okay, alright, next one, number 6. It says 0.21 is on a circle whose center is -4, 3. Write the equation of the circle. Okay, so there are 2 points. So I need the center and I need the radius. They give me the center. Okay, got that. Check. I need the radius. How do I find the radius? I need this distance. I need the distance between the 2 points. This is my radius. Okay, how do I get that distance? I'm going to have to use the distance formula. Let's let these be my 1s, x1, y1. Let's let these be my 2s, x2, y2. So my radius, or my distance in this case, is equal to the square root of the differences of my x's, x2 minus x1 squared, plus y2, 3, minus y1 squared, minus 1 squared. Okay, that becomes the square root of 40. I'll just leave it as that, square root of 40. And then, and now I'm ready to write my equation. Okay, so my equation is, remember my equation is x minus h squared. Let's go back up here. My equation is x minus h squared. Okay, so it's x minus, okay, and what is my center? My center is -4, -3. Okay, so let's come up here and write this up here. The center is -4, 3. Okay, so it's going to be x minus my h. Remember your center, this is h, k. So it's x minus that. So then once again we have this double negative squared, and then plus y minus k squared, and that's going to be equal to r squared. Okay, well the radius is the square root of 40, but I got to square that. Okay, so this becomes a positive, that becomes double negative, that becomes a positive, x plus 4 squared plus y minus 3 squared. Now I've got to square the square root of 40. When you square the square root of something, you just get itself. So you just get 40. Okay, so there is the equation of my circle. X plus 4 squared plus y minus 3 squared equals 40. Okay. Alright, so let's go on to number 7. Number 7. Coming down the home stretch here, guys. All right, so this one is a little bit, this one's a little bit tricky, guys. I'm not going to lie, a little bit tricky. All right, so we have the endpoints of the diameter of a circle are 5, -7 and -2, -9. It says write the equation of the circle. Okay, so what are the two things I need? I need the center and I need the radius. I need the center and I need the radius. Okay, so we have 2 points on the circle. I don't have either of them. I don't have the center or the radius. Okay, so how do you think I'm going to solve this problem? Well, why don't we connect the 2 points? Okay, so there's the distance between the 2 points. To find the center of this circle, which equation do you think I can use? Distance formula won't help me find the center. But if you remember from our warm-up, we did the midpoint. Okay, so if I find the midpoint between these two coordinate points, that will be the center of my circle. Okay. All right, so midpoint, if you remember, is just going to be the average of my x's and the average of my y's. You add the x's, divide by 2. You add the y's and divide by 2. This is like my x1, y1. This is my x2, y2. So let's add the two x's together. So we're going to add the 5 plus the -2, or 5 minus 2. Divide that by 2. Let's average the two y's. -7 minus 9. Divide that by 2. Okay, so 5 minus 2 is 3 over 2. So my midpoint is going to be 3/2. That's my x coordinate. -7 minus 9 is -16. Divided by 2 is -8. Okay, so this is my center, which is basically the midpoint of those two lines. The center is 3/2, -8. Okay, look at your graph. Do you buy that? Does that make sense? 1.5 and then down 8? Yeah, that makes sense. Always check your answer and make sure it makes sense. Okay, so that gives me the center. Now I need the radius. Okay, well, to find the radius, don't I need the whole diameter? If I found the whole diameter, couldn't I just cut that in half and find the radius? Yes, Mr. Manish, you can do that. All right, so the distance, or the diameter in this case, d for distance, d for diameter, is going to be x2 minus x1 squared. It's just the differences of my x's. I'll get my camera to come back in focus. There you go. Welcome back. All right, so it's going to be x2, -2, minus x1, minus 5. We're going to square that, plus the differences of my y's. y2 minus, don't forget this little tricky, we're subtracting a -7 here, and then we're squaring that. So that becomes the square root of -7 squared. And then that's going to be -9. That becomes +7. Okay, so -9 plus 7 is -2 squared. So that becomes -7 squared is 49. Square root of 49. -2 squared is 4. 49 plus 4. So the distance is equal to the square root of 53. Okay, that's the distance, or in this case the diameter. Okay, I don't want the diameter. I need two things for a circle. I need the center, I need the radius. Okay, all right, radius. How do I find the radius? I'm just going to cut that in half. So the radius is the square root of 53 divided by 2. Square root of 53 over 2. Okay, got the radius. All right, so now I've got the center and I've got my radius. All right, check, check. Now I'm ready to plug this into my equation. All right, so remember it's x minus h squared plus y minus k squared equals r squared. Okay, so my equation is going to be equal to x, all right, flippy flip, there's my center, I got to flip that. So it's going to be x minus 3/2 squared plus y, I got to flip that sign, y plus 8 squared, and then this is my radius, but remember in the equation it's got to be r squared. Okay, so I've got to square this whole thing. So if I square that whole radius, when I square the square root of 53, I just get 53. And then on the bottom, I got to square the top and the bottom. When I square 2, I just get 4. So my final equation is x minus 3 halves squared plus y plus 8 squared equals 53 over 4. And that is the equation of my circle. Whew. Not gonna lie, guys, that's a little tough. That's a little tricky. Okay, so I've only got about 5 minutes left on this video. I need to cover the second half of this lesson, so I'm actually going to stop here, and I'll just call this part 1 of this lesson, and then I'll make another video, part 2, to finish up the second part of the lesson. So we'll see you on the next video.